Hello everyone. Today I'm going to present my internship project, which is on washing machine simulation. We'll be developing a embedded system of a washing machine. This internship was provided by Emertxe Information Technologies on the topic embedded system. Before we begin, let's have a brief introduction of me. My name is Anshuman Kantpal. I am from NIT Hamirpur. Let's begin. Today we will see introduction, what are embedded system and its components, the software used for the project simulation, the microcontroller which is PIC 16F877A. What is the language used for programming is embedded C. We'll have a brief look on embedded C, how it is different from normal languages, the peripheral description of the project, and at last we'll see the simulation. So let's start. What is embedded system? An embedded system is a microcontroller based system built into a larger device and designed to control, monitor, or assist the operation of equipment, machinery, or processes. Basically, everything which we use in our daily life uh, comprises of embedded system, like your washing machine, microwave, or anything such kind composed of embedded systems. The characteristics of embedded system are it is task specific. Basically, all the systems which are based on microcontroller are usually task specific. They have a fixed task to perform. So it is for real-time operations, means it responds with strict time constraints. Resource constraint, embedded system do not have a large memory, processing power, energy because they are built for a particular task. Embedded system is not a standalone system. It cannot be a system which can have its own intelligence or which can run on its own. Something requires for driving it. Types of embedded system. Standalone embedded system works on its own without a host. Real-time embedded system means these type of embedded systems are used where we have a strict time constraint, such as pacemaker. Because here we cannot neglect the time. It may result into a serious consequence. Networked embedded system, communication of embedded system mainly in smart home devices like your smart light, smart television. They are a kind of embedded systems. Mobile embedded systems are, which as the name suggests, we can take it anywhere. They are mobile. Hybrid embedded systems are combination of these type of embedded systems such as Tesla car, which are real-time networked and mobile. So components of embedded systems. Embedded systems consist of a core. Core generally consists of the processing unit, which is CPU, and we have some input ports, output ports, memory, and other devices. Likewise, you have seen the mobile. Mobile has some input ports, some output ports. Mobile has a memory, and we could also connect some other devices with the mobile. Similarly, every embedded system has a general structure like this. It has system core, memory, input ports, and output ports, and other device. We do have various communication protocols that are used for different purposes like UART, I2C serial communication. So let us have a look what we are simulating today. The project which is made is based on PIC microcontroller. So before jumping into the project, let us have a brief look on what is a PIC microcontroller, what the features it comprises. It is a 8-bit microcontroller. Means the CPU is capable of processing 8-bit data. Whether it be anything, it will be of 8-bit. It has a 14 KB of flash memory for program storage, 368 byte of SRAM static RAM for data storage, 256 byte of erasable electronic programmable ROM for non-volatile data storage. It operates at a clock frequency of 20 MHz, provide 33 general digital IO pins. IO pins are generally input-output pins. Some pins are used for giving the input to the controller and some are used for giving output to some another device. It includes 5 IO ports, port A, port B, port C, port D and port E. Offers 3 timers. Timer are basically used for counting the machine cycles. Timer 0, timer 1 and timer 2. Timer 0 and 1 are of 16 bits. Timer 2 is of 18 bits. It supports internal and external interrupts. We will have a look on what are interrupts. Features on 8-bit channel, 10-bit analog to digital converter. Contains USART module for serial communication. Serial communication is basically communication where the data travels bit by bit, as the name suggests, serially. Provide pulse width modulation capability for control application. Includes a watchdog timer to recover from software failures. Supports in-circuit serial programming (ICSP). Designed for low power consumption, suitable for embedded applications. So, a microcontroller needs some instruction. The instructions are given by through a code. What we have written in the code, the same microcontroller obeys. For example, you have programmed anything like a simple Arduino board. You have to push a code and it does what the code says. So every microcontroller needs some programming. The brain requires some programming. So PIC microcontroller is programmed in embedded C. So let us have a clear look what makes embedded C different from C. Usually the core microcontroller are programmed in assembly languages, and for embedded system C is a kind of high level language. Embedded C lies between assembly language and the C language, which is a kind of language which can interact with the hardware. C alone cannot directly interact with the hardware. Embedded C can directly interact with the hardware as assembly does. So it is a combination of C language and assembly language. Assembly language is generally hard to learn and it is more complex. C gives us a easier way to communicate with the microcontroller. Embedded C is a kind of mixture of both languages. So embedded C is an extension of C programming language, specifically designed to program embedded systems and microcontrollers. It allows direct access to hardware like ports, memory, timers, and peripherals. So feature of embedded C based on the standard ANSI C language with additional support for microcontroller feature. We can directly program the registers. We can directly set the register through embedded C, which is not possible in case of normal C language. Assembly does, but assembly is a complex language. Embedded C allows us easier way to program a microcontroller. Allows direct manipulation of hardware registers and memory addresses. Offers high performance with low level hardware control. Efficient in terms of memory and processing speed. Highly portable across different microcontroller platforms, example PIC, AVR, and ARM. Using real-time embedded systems, control system, and device drivers. So next we move on to peripherals. A microcontroller, as we have discussed earlier, has some I/O ports. So peripherals are the devices which are connected externally to the microcontroller that help it interact with physical world. They provide input-output communication capabilities to embedded system. As you've seen, your mobile phone consisting of audio jack, which is kind of peripheral. You can uh, insert the audio jack and you can get the output on a speaker. So this is a kind of example for of a peripheral of a microcontroller. So types of peripheral in embedded systems. Input peripheral. As the name suggests, input peripherals are meant to give input to a microcontroller. Example switches, keypads, sensors. Sensors can be of any type. Output peripherals, devices to receive the signals given by the microcontroller. Example LEDs, buzzer, motor, LCD. Likewise, we will see after that washing machine we give we can take output on a screen, which is a kind of output peripheral. Communication peripheral that are used to send data between the microcontroller and their devices. The protocols which are used are UART, SPI, I2C, USB, or Bluetooth. You are familiar with these protocols and communication peripherals. Memory peripherals provide additional storage if you want that your microcontroller should store something extra or should store the previous data which will be of use for any of the purpose. So we have memory peripherals, or for example flash card, SD card. As in earlier mobiles, we used to use SD cards for extra storage. So a common thing which a microcontroller has, a feature which is called interrupt. Interrupt, as the name suggests, it is a kind of something which halts the main program execution and diverts the processor to run a special routine called ISR, which is interrupt service routine. So, for example, let me give an example of something. Suppose you have a fridge, and the purpose of fridge is to cool something, but suddenly a short circuit happens in the circuit of the fridge. So it will temporarily halt the program, which is the cooling, and it will respond to that immediately to that critical event, which is kind of short circuit or a overflow, we can say. So why interrupts? Interrupts are meant to handle real-time events without constantly checking, increases efficiency by letting the process perform other tasks, saves power by allowing the system to sleep until an event occurs. So type of interrupt, in microcontroller we have external interrupts, internal interrupts, triggered interrupts, and timer interrupts. So external interrupts that are triggered by external hardware devices. Suppose you push a button on any device, so it will temporarily halt the main execution and it will respond to the event which a push button does. Internal interrupts are interrupts that are generated by internal devices, internal peripherals, such as sometimes an overflow can occur, which will result that the microcontroller should respond to that internal interrupt. Interrupts are basically a kind of program. ISR is a kind of program which is called internet subroutine. So what happens when an interrupt occurs is the program, when an interrupt occurs, the program, the microcontroller stores that address of a main execution, jumps onto the ISR, perform the ISR, then returns back to uh, the main execution. The addresses of these are stored by stack pointer, which is common in all type of microcontrollers. As trigger interrupts, they are activated on signal transitions like rising edge or falling edge, commonly used for external interrupt. Timer interrupts occur when a timer overflows a specified value, which might be due to some, uh, what we can say, which might be due to an unintended event. So now we see what we have used, how we had made the project, what are the tools required for the project. So for programming, we have used MPLAX LabX IDE. IDE means Integrated Development Environment, where we code. So we will write the code on MPLABX IDE in embedded C. The compiler used is XC8 compiler, which is used for generating hex file. The microcontroller understands the hex file, and XC8 is a compiler for 8-bit PIC microcontrollers. PixSimLab is a simulation tool, which is the interface of a microcontroller where we can simulate our circuits. And the microcontroller uses 60 PIC16F 877A microcontroller, and we have peripherals like LCD, keypad, motor, and a buzzer. So let's simulate. So let me take you to the MPLabX IDE. So this is a general interface of MPLabX IDE. Uh, from here we can create a new project, but I have already created, but I will show how to create. Just click on the new project, give your name to your project, select the select embedded, select application project, then select the for PIC microcontroller use baseline 8 MCUs. Here you can select PIC16. You have to use mid-range 8-bit MCUs. Here you can select PIC16 F887A. uh, you will easily find it. Mm. So here is PIC 16F8778, and just you have to click next. You have to select the compiler, then you have to give your project name, and when you will give your project name, just click on source files, create a new file which is main.c, write your code. Let me explain you the code. Here we have set the registers, we have mapped the switches, and these are the characters which will appear in our LCD screen. And this is the basic logic. If the button are pressed, basically these are if else conditions. And we have been given some delay, because delay is an important aspect when you are dealing with microcontrollers or any embedded system. In software we do not require delay because they are fast, and there is no use of delay. the, they are purely based on the processor, not the hardware. But in case of hardware we need some delay, which is essential for the switching transitions between the various component on an embedded system. So once you are done with the code writing, just simply click here, build the main project. It will take a few seconds to build. Uh, so when it is built successfully, it will write build successful. You just need to remember this address. As we have stated earlier, the microcontroller understands the hex file, so we have to push the hex file into the microcontroller. This is the address of my hex file. So once when you compile, it will show your address, which might be different. So let's see. So this is the basic interface of PICSIM lab. From here you can select the board. For PIC microcontrollers we generally select PIC Genius. It will take some time. And from microcontroller we select PIC 16F877A. So now we are ready with the simulation. From the files, you just go into it. This is your hex file which is generated. Open this hex file. It will get load to the microcontroller. And as we have programmed, press switch S4 to on. We have mapped the switch S4 SW4 to RB4. When we click on RB4, it gets on. And for selecting the board, we have used RB3 button. So you can select, these are the modes: heavy, normal, spin only, wash only, quick wash. For selecting any mode, we have mapped the button RB0. So the mode is now confirmed. And we have given some delay. Till the delay, the fan will be on and it will do the process which is meant to be done. So once the delay is over, that automatically shuts. We can on it, off it by the reset button. Reset will restart the program. Similarly, you can map onto any button. Here you can select any other mode also. Heavy, running the simulation, heavy mode confirm. You can add different features. It has a display, you can add a timer here, it has a buzzer, and this is a kind of keypad in the PIC 16F887A. When you will go into the real board also looks like the same. Here we have a port for serial communication. This is a cooler, and we have buzzer and LEDs. These LEDs correspond to different operations. That is LED1 for port D, LED1 for port B. These are different LEDs. They turn on and off by these buttons. This is the main microcontroller, PIC16F877A, and here we have a reset button. So this was all about the project we have made. So this was an overview about how the embedded systems are made. This is a kind of example. We can have many other examples in our daily life, like microwave oven. A mobile is also kind of embedded system. So this is all from my side. Uh, this is the code which I've already explained, and thank you very much.